Mathematics, grade 10, paper 1. Okay, so unlike before COVID, most of the papers were complete. But between 2020 and 2022, some papers had some content trimmed out, and some examiners would test some topics and some others were left out. But it seems like we're back to normal, where we have to test on almost all the topics, especially for paper 1. Now, under paper 1, what topics can we expect in grade 10? One is algebra. So algebra is just a wide topic, which in normal cases for grade 10s, it should carry around about plus minus 30 marks. Okay. Remember, the grade 10 paper is normally out of 100 marks for 2 hours. Okay, so plus minus 30 marks. Can say 5 plus minus, or 30 plus minus 5, round about it. Then under algebra, what do we expect? One, we expect something to do with factorization. We need to know how to do the factorization and the different methods. Okay, we know we can talk about factors, we can talk about grouping, we can talk about the quadratic trinomials. We can also talk about factorizing the sum and the difference of 2 cubes. Even the difference of 2 squares can also be tested under factorization. So that we just need to know. And then 2, we also have what we call the exponents and indices. We need to know our laws, okay? If you're multiplying numbers with the same basis, what happens to the exponents? We just add them. Then when dividing numbers with the same basis, what happens? You subtract. Then if you have 2 exponents multiplying each other, it would be something like that. Okay, an exponent raised to another exponent would be this format. Then still in grade 10, we could have something like that. Okay, and then anything to the exponent of 0 is always 1. That's under the definitions. So the laws and definitions of exponents, we need to at least remember. Then still under algebra, we have our equations. Okay, under this in grade 10, we have quite a lot. One, we need to remember our linear equations, not so much tested. We have the quadratic equations, okay, that require factorization. We also have the exponential equations. This we need to remember. Then we also have what we call the literal equations, where we have to make something the subject of the equation. Okay, we're just dealing with variables there. And then lastly, probably the simultaneous equations. Simultaneous equations. So with the simultaneous, just have to get one value of x and one value of y for grade 10s. And then besides the equations, is there anything else? Not really. I think that is it. That we normally test. For as long as we test about the factorization, the exponents, the equations. All right, then topic number 2 in paper 1 is what we call the number patterns. So number patterns for grade 10s is strictly the linear, or sometimes we call it the arithmetic. Now we know that the linear has what we call a constant difference, which constant difference is between consecutive terms. So in other words, for us to get D, we get T2 minus T1, or T3 minus T2, and so on and so forth. And then the general term is always AN plus a B, or BN plus a C, or whichever format you want to write it out. Now, what happens in grade 10 is that it could come just as plain numbers, where they give you 2, maybe 5, and then 8, 11, and then they ask you a whole lot of questions, writing the next term, determining the general term, which term has a value of this, or in which term can we get this much of blocks or sticks and everything. Okay. It could also come in the format of fractions. You can have 2 over 4, maybe 5 over 7, and then 8 over, can have 10, something like that. You can ask for the next time. So the top part forms a pattern of its own. The bottom part also forms a pattern of its own. So if we can get the general term of the top part over the general term of the bottom part, then we have the general term of the entire number, the entire pattern, or the entire sequence. And then we could also use diagrams. Okay? Diagrams that form patterns. We could look at different designs, different blocks, matchsticks being arranged, and things of the sort that can still unfold number patterns. So the mark allocation of number patterns for grade 10s is not that a lot. We normally look at plus minus 15 marks. Okay. Then topic number 3 under paper 1 is what we call the functions. Functions, not so much, plus minus 25 marks. Now, functions can also be known as graphs. Okay? Now, what graphs do we find under paper 1? Number 1, we have what we call a straight line. We need to know at least how to sketch how the straight line is described. So it's normally in the form of mx plus c, where our m is the gradient, and then c is the y-intercept. So grade 10s, how do we get the gradient? You said changing y2 minus y1 over x2 minus x1. This we need to know. Okay? For you to get the y-intercept, it will be all about substitution into this general format. Then the second graph that we need to look at and pay attention to is the parabola. Okay? So the grade 10 parabola will always be given in the form of ax squared plus a b. In most cases, we say plus a q plus a p. We just call it a q in this case. Okay, just plus a q. Now we know that if our a is positive, we're going to have a smiling parabola. But if our a is negative, we're going to have a frowning parabola. This q represents what we call the y-intercept, the point where the graph is touching the y-axis. Okay, so that is the general form of the parabola. What we need to know about the domain of the parabola is that x is an element of real numbers. So which means this parabola can stretch to the left and then to the right also of the axis. Then when it comes to the range, y will be either greater than the TP of y, or y should be less than the TP of y. It can be greater if we have a minimum. In other words, it's a smiling parabola. Then that's how the range should be written. It can be less than if we're talking about the maximum. Okay, if y is having the maximum value. So we need to get a point, the y value of the turning point, and then get that. Then the axis of symmetry. Axis of symmetry, that is a point that completely breaks down the parabola into 2 equal parts. Okay, it divides, it separates. How do we get that axis of symmetry grade change? It's x is equal to minus b over 2a. So that we need to know. Then the other thing is, let's say if we ask for x-intercept grade change, just replace y with a 0. If they ask for y-intercept, then replace x with a 0 and do the calculations. So that is to do with the parabola. Know how to sketch, because sketching is going to involve getting the intercepts as well. So at grade 10, we don't really restrict learners. You can even use your table method and do the sketching. Then number 3, we have what we call the exponential graph. So exponential is usually in the form of y is equal to b to the x. We can put a Q for greatness sometimes. Okay, so Q represents what we call the asymptote. Asymptote is a line that the graph cannot cut. Okay, then if your B is greater than 1, we expect this this exponential to be increasing. That would be the shape. But if B is between 0 and 1, in other words, it's a fraction, we expect your exponential to be decreasing. Then number 4, we have what we call the hyperbola. Because it looks like I want to talk about the hyperbola more than the rest. So hyperbola has 2 formats. We can have a hyperbola in this format. That is if our A is greater than 0. But if A is less than 0, then the hyperbola is going to be in this format. So the general equation of a hyperbola, how do we tell that we have a hyperbola? When we have A over X plus maybe a Q. Okay, A over X plus a Q. So this hyperbola has what we call asymptotes. Okay, so the vertical asymptote, okay, vertical asymptote, X will always be a 0 for great chance. And then Y will be equal to this Q. In other words, we can shift it up or down and all of that. We just need to remember that. Okay, so when it comes to the domain returns, domain will represent X values. So X will be an element of real numbers. X should never be a 0 because 0 is an asymptote. Graph cannot pass them. When we talk about the range, Y is an element of real numbers. Y should never be equal to a Q. That is a Q. Because Q will be your asymptote. So when it comes to the y-intercept and x-intercept, we just apply the same format of y is equal to 0 for x-intercept, and then x is equal to 0 for the y-intercept. So basically, that's all that we need to know under the functions. For as long as you know how to do your sketching, for as long as you can tell what type of graph you've been given, then we are good to go. Then the next topic will be finance. Okay. Under finance in Britain, we expect people to know about some exchange rates. Know how to work around with currencies. People must know about simple interest. Okay. The difference between simple and then compound interest. And then people must still know how to work with what we call hire purchase. Okay, so hire purchase in most cases goes with simple interest. They move hand in hand. Then what else do we need under finance? I think that's all. Exchange rates, simple interest, compound, and then hire purchase. So that's all we need to know. Okay. For things like inflation, what type of interest is there? We know that it's compound interest. Even sometimes we talk about depreciation, but not so much in return. So finance will account for plus minus 15 marks. Then lastly, number 5, we have what we call probability. So probability in Britain is still plus minus 15. It can be less or more, just around that, so that the paper is out of 100. Now, under probability, Britons need to know the difference between independent events and dependent. We need to know about mutually exclusive events. Okay. Britons need to know that probability rule A or B is equal to probability of A plus probability of B minus probability of A and B. Okay. Then Britons also need to know how to use Venn diagrams. And their Venn diagrams will be restricted to probably 2 sets. Okay, and we need to know how to work around with those 2 sets to determine what is missing. And then the general probability, where they ask you, let's say if we have 3 green sweets in a bag, 2 blue sweets, what are the chances of picking, let's say, green sweets? So that is more like general probability that we need to know at least at grade 10. So grade 10s, I'm just gonna get a random paper and try to go through that random paper. Okay, I'll try to be as fast as I can because of time. Okay. So question number 1, said factorization. So this is algebra. Question number 1, they're telling us to factorize the following for you. Now, no one is going to tell you which method to use. Grade 10s, we just need to be sensitive to know what we need to do. Okay, or which method to apply at what time. So this is x squared plus x minus 42. So this is a trinomial. So with the trinomial, we know that we need to look for the product and the sum and all of that. So the product is negative 42, and then our sum is 11. Which two numbers we multiply to give us negative 42, but when we add them, we get 1. So the only numbers I'm seeing will be 6 and 7. Okay, one of them has to be a negative. So I'll make 6 a negative. If I multiply this, I get a negative 42. When I add these two numbers, I get 1. So I'll open my 2 brackets and say x minus 6, x plus 7. And then that's my answer. Okay, so 1 mark for each vector. All right, then 1.1.2, how many terms do we have here? We have 4 terms. But as long as we have 4 terms involved, we need to apply the grouping. Okay, let me just jot that beside. We have 2ab squared minus b cubed, okay, minus b cubed plus b squared minus 2ab minus 2ab. So what we're going to do is, okay, so what we're saying is that when we're grouping, just take 2 terms. Okay, I'll just consider the first 2, just put brackets, and then even the last ones. Okay, something like that. Just make sure there's a plus sign somewhere. So if this was a minus, yes, put a minus together with a b squared and then introduce a plus, a small plus sign. So what we see as common in the first bracket, I'm seeing a b squared. So I'll take out the one with the smallest exponent. I'll be left with 2a minus a b. Now, what do I see in the second bracket as common? It's just a b. I'll say plus b is out. I'll be left with a b minus a 2a. Now, these 2 brackets kind of look the same, but things have been switched around. The b here is negative, the b here is positive. So the only way to solve this out is by taking out the negative sign. So factorize the negative sign there. You're going to have a negative b, and everything must swap around. So what was negative becomes positive, what was positive becomes negative. Then you can see that these 2 brackets are the same. I'll have 2a minus b, and then I'll be left with a b squared minus b. So still I can see there's a b common, so I'll take it out as well. So b into, I'll say b minus 1, and then this becomes 2a minus b. So that will be our answer for maths. So alternatively, since we can see that there's a b everywhere, you can start by taking out that b before you do the grouping. Okay, so that is question 1.1.2. Then 1.3. This is a 3. Then this is a 27 over x squared. Okay. So it's like this a 3 minus 27 over x squared. What I'm seeing is this x squared. 27 cannot be expressed as a square. But what I can see is that 3 and 27, there's something common. Take the 3 out. I'll be left with 1. minus 27 divided by 3, that's a 9 over x squared. And this is a difference of 2 squares. So if 3 is out with the difference of 2 squares, just open 2 brackets. One bracket will have a plus, one bracket will have a minus. So it's 1 plus, 1 minus, because the square root of 1 is 1. What's the square root of 9? It's a 3 over x. And that's 3 over x. So those will be the answers for that question. Then 1.2, 1.2 products multiplying. Okay, so with this, we apply what we call the FOIL. Is it the FOIL? Not really FOIL as such, dots and stuff like that. So I'm going to use 4a squared. It's 4a squared. FOIL is usually for square brackets. Minus 2ab minus 3ab plus b squared. We are multiplying by what? Okay, I'm multiplying it by 2a plus b. Multiplying it by 2a plus b. So by just looking at this, someone can just draw a conclusion and say this is the sum of 2 cubes. Okay, because this is 2a plus b. When I square this, I get 4a squared. When I multiply this and this, I get a 2ab. When I square that, I get a b squared. So this is going to be like 8a cubed plus b cubed, because this is the sum of 2 cubes. Alternatively, you can open 2a multiplies everything, and then b multiplies everything. Then remember to collect the like terms. We're going to end up with the same step. Okay, then 1.2.2. Let's open this up. So these are exponents. Okay, so you're going to say 8 to the exponent of negative a third. Multiplying by x to the 12 times negative a third. Multiplying by 2x to the negative 4. Is this a subtraction? Yes, we are subtracting x to the negative 8. Okay, we need to do the magic here. Multiply with the same basis. We have to add up the exponents here. Now we know that for as long as the exponent is negative, it can become a denominator. Why don't I put it aside? You say x to the negative 1/3. Multiplying by x, I'll simplify this to just make negative 4. Okay, x to the negative 4. And then followed by 2x to the negative 4. This is 2x to the negative 4. Is that correct? Yes. We are subtracting x to the negative 8. Okay, so we say this can be the same as 1/8 to the third. And remember, 1/3 is more like the cube root. 1/2 is like the square root. Let me just simplify this. This is a 2x to the negative 8 minus x to the negative 8. So we know that the cube root of 8 is 2. So it's like a half times 2. Then x to the negative 8 minus x to the negative 8. This and this gives us a 1. So 1x to the negative 8 minus x to the negative 8, we get a 0. So that is that. How many marks? 3 marks. Then 1.2.3, for as long as we have minus signs involved in exponents, there has to be factorization. I'll put it aside also. So we have 7 to n plus 1. Okay, that's 2n plus 2 after 1. Okay, we are subtracting 3 times 7 to n plus 1. And then I'm dividing by 49 times. 49 to the n times 4. Okay, so step number 1 is for you to change everything to simpler bases and then expand. So let me start by expanding the top part since everything is in simpler bases, which are prime bases. So that is 7 to the 2n times 7 to the 2. Okay. This is the same as 7 to the 2n times just the 7 to the 1. I'm using the reverse of the multiplication rule that when I multiply numbers in the same basis, I must add up the exponents. Then when I change 49 can be written as 7 squared. So that's going to be 7 to the 2n multiplied by 4. I don't need to play with the 4, leave it, doesn't have any n. Then the top part, what do I see as common? 7 to the 2n. I'll be left with, this is a 49, or 7 squared is 49. Then 3 times 7, that's a 21, over 7 to the 2n times 4. Then 7 to the 2n cancels out. What is 49 minus 21? That gives us a 28. We're dividing it by 4, which means our answer is just a 7. So that is how we go about that. Okay. Then question 1.3, they're telling us that if 6 to the 7 is x, determine the value of 6 squared, 5 cubed, 4 to the 4, 3 to the 5 in terms of x without using a calculator. This is ridiculous. Okay, so what I'm saying is that I need to create a base of 6 to the 7, and then I'll equate that to x. So what I'm going to do here, I have a 6 squared. 5, there's no way 5 is going to be changed into 6. So I'll just leave that 5 cubed as 1.5. Then 4, I know 4 has an element of 2. So I know that 4 is 2 squared. And then I have a 4 up there. Okay. So that's going to be the same as 2 to the 8. And then 3, I can't break it further. So I know when I multiply 2 by 3, I get a 6. So I need to split this 8 so that I have an exponent of 5 and whatever is left. So that's going to be 6 squared times 1.5 times 2 to the 5 and then 2 cubed times 5 cubed. Is it 5? No. It's 3 to the exponent of 5. Let me just erase this. It's saying 3 to the exponent of 5. Okay. And then I know that this and this, I can multiply it and get a 6 to the 5. So 6 to the 5 multiplied by my 6 squared. So this and this is out. I'm left with 125 times 8. 125 times 8. So this gives me 6 to the 7 times 125 times 8, that's 1,000. So 6 to the 7 is x, which means our answer is 1,000 x. So that's how I would have gone about it. Then 2.1.1. 2.1.1. Okay, 2.1.1, we just need to play around with this root x of 16 is equal to 2. So one thing we need to remember is whenever we have, let's say, the cube root of the number, it's that number to the exponent of 1 over 3. So this is going to be like 16 to the exponent of 1 over x must give us a 2. Okay, then we just need to change this 16 to a base of 2. And we know that 16 will be the same as 2 to the exponent of 4. Okay, if 16 is 2 to the exponent of 4, remember it's a 1 over x, so it's like 2 to the 4 over x is equal to 2. Then the bases are the same, then we just have to consider the exponents. So what that means is that if I have 4 over x is equal to 2, no, it's not 2, it's a 1, because the exponent up here is a 1, which means my x is going to be just a 4. So the 4th root of 16 gives us a 2. So here we're saying x is a 4. Then 2.1.2, x over x minus 3 minus x over 2 minus x is equal to this. They want us to solve for x. So this question involves some element of factorization, but we also need to determine our common denominator this side. Okay. So what I'm going to do is let me just write to this side. Okay, so they're telling me so it's x over x minus 3 minus, I don't know whether I should just cross multiply there and then, so that we save time. Okay, so that's going to be x into 2 minus, let me just use that other page. Okay, so we said we could use the cross multiplication. Okay, so that cross multiplication is going to be this multiplied by that, and then that. I'm just focusing on the left-hand side first. So I'll have my x into 2 minus x, then minus x into the x minus 3. Everything is over this product, which is x minus 3 into 2 minus x. Should be equal to, I can factorize this. Remember, it's 2x squared minus 25. There's nothing common. There is nothing common. Can't be a difference of 2 squares. So I'm just going to leave it the way it is. Okay, that's 2x squared minus 25. At the bottom here, this is a trinomial. I can have my 2 brackets. That's x minus 2, x minus 3. Okay, I'll open up the top part here. That is 2x minus x squared minus x squared. That one, that is plus 3x over what I can see is that these brackets just look the same as these others. Okay, so the only difference, I'll take out a negative sign there. So it's going to be negative this. The negative I'm taking out is from this bracket here, so that it is x minus 2. It's equal to 2x squared minus 25 over x minus 2, and then x minus 3. So then the denominators are just the same on either sides, which means they can be cancelled out. So this 3 cancels that one, this cancels that. I'll only be left with the negative. Let me simplify what is on top. That's negative 2x squared plus 5x. All this is a negative, is equal to x squared minus a 25. So that is 2x squared minus 5x is equal to x squared minus a 25. So the 2x squared and the 2x squared, they're going to cancel out, because when you transpose one, the other one cancels. So you'll be left with negative 5x is equal to negative 25. Divide both sides by negative 5, which means x will be just a normal 5. So that is how I would have gone about with this question. Then 2.2, they want us to solve this inequality. So with this inequality, the target is to leave x in the middle. Okay, so start by eliminating the 2, multiply through by 2. So 0 is less 6, less x, sorry, minus x is less than 4 times 2 times 2 times 2 everywhere. Then move the 6. I'll have negative 6 is less negative x is less negative 2. Okay. Then when I try to divide through by 2, the signs are going to change. I divide through by negative sign. So that's going to be a 6 is greater than x is greater than a 2. Then I can switch this down. And then I'll have 2 is less x is less 6. That is the first part. Then write down an integer that will make the equation valid. So we know that integers are both positive and negative numbers. So which number can make this whole thing valid? Which number is in between 0 and, does that make sense? When I say 0 and 2? No. We say the answer is between 2 and 6. So we can have a 3, we can have a 4, we can have a 5. So all those could be valid answers for 2.2.2. Okay, 2.3, which is the simultaneous. We have various ways of doing the simultaneous. Okay. What I usually encourage learners to do is use the elimination for grade 10. Because substitution might be a bit tricky, but elimination will be just tricky. But whichever format you feel comfortable with, still use it. So if I call this my equation 1, and then I call this my equation number 2, let me just try to rearrange them. I have 2x minus 4y is equal to 6. This is going to be a 3x minus 5y is equal to 10. Now, if I say I want to eliminate, let's say, x, then I'll get the coefficients here multiplied by the second equation, get the coefficient here multiplied by the top equation. So I'm going to say times 3 and then times 2. So the top equation is going to be 6x minus 12y is equal to 18. The bottom one will be 6x minus 10y is equal to 20. Then I'll do my subtraction. So this 12, negative 12 minus 10 is going to give me minus 2y. 18 minus 20 is a negative 2. Divide both sides by negative 2, which means y is a 1. Then get this 1 for y and replace it either in equation 1 or equation 2. So if I use equation number 2, I'll have 3x plus a 5, sorry, it's minus a 5. 3x minus a 5 is equal to 10. Then I move the 10 that side, becomes 15. 3x is 15, divide both sides by 3, which means x is a 5. So that is how I would have obtained that for 5 marks using elimination. With substitution, you can divide this by 2 so that you have your x minus 2y is equal to 3. Okay. And then make x the subject so that x will be 3 plus 2y. Let me just do it aside. So we say x minus 3y is equal to 3. Is that true? X minus 2y. This is a 2y. So when I leave x alone, x is going to be 2y plus a 3. And now I have to substitute 3x. We say plus, it was a minus 5, guys. 3x minus 5y is equal to 10. Let's just confirm. 3x minus 5y is 10. So where there is x, we just replace this. So if this was equation star, this is equation number 2. We just replace this in where there is x, we put that. So 3 into 2y plus 3 minus 5y is equal to 10. That is 6y plus 9 minus 5y is equal to 10. Okay. Please behave. Behave. So 6 minus 5, that's a y. Take the 9 that side, which means y is a 1. Then go back to the equation star and get x. So that is 2 times 1, which is 2 plus 3. We get a 5. So still same thing. Reason as to why I like elimination, chances are few of messing with signs. Okay. Question number 3, which is the number patterns. There we go. We have the fractions. -3, -6, -9. 5, 9, 15, and so on. Write down the next 2 terms. So we need to know how is the pattern going. So when you look at the top ones, like we're just subtracting the 3, so subtract 3, subtract 3. So the next one has to be -12. At the bottom, it's like we are adding 4, so over 17. You subtract 3, -15, and then you add the 4, which is a 21. So that is our pattern. Then they want us to get a general term. So with the top part, it's like -3, we are multiplying it by natural numbers. So the top part is just going to be like a 3n, but negative, because -3 times 1 is negative, -3 times 2 is -6, and so on and so forth. Then when you look at the bottom part, since we are adding 4, okay, 5 plus 4 is a 9. So the common difference is a 4 everywhere. So I'm going to say 4n, and then what is 5 minus 4? That is a 1, a positive 1. So I have 4n plus 1. So this becomes our general term. Use whichever methods, please, you can determine the arithmetic, okay? The ones you were taught, please. Then calculate the value of the 50th term. So 50th term is like T50. Where there is n, replace the 50. So -3 times 50 over 4 times 50 plus 1. So this is -1 over 50 over 4 times 50 is 200 plus 1. That's going to be 201. You don't need to simplify, just leave them the way they are. Then consider the following sequence of e's. Then how many blocks will be needed to build the 50th E? So we need to know how is this pattern of E growing, especially with the number of blocks that are used. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 blocks, first of all. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 blocks. Then let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so we have 15 blocks. So it's like we are adding 3 blocks, but starting with 9. So when they talk about 5th block, or the 5th E, the 4th one is going to be +3, which is 18, and then +3, which is a 21. So we need 21 blocks. Then the general formula. So remember, general formula is the same as the general term, is the same as the n term. Okay, so for you to get that, get the common difference, which is 3, attach the n. Then get the first number, you subtract the common difference. So 9 minus 3, you get a 6, which is positive. So that is our general term, or the general rule. Then 3.2.3, they are telling us that 125 blocks are needed to build a certain position or a certain term. Can we determine this I? So where there is Tn, we put 125. We equate it to 3n plus 6. We want the position. So move the 6 to the left. So 125 minus 6, we get 119. Okay, 119 is equal to 3n. Then we divide it by 3. We have 39.666. Did we make a mistake? Okay, so we're saying we're getting 39.667. But in number patterns, we should never get a position that is a decimal. Okay, because if we set 39, then the blocks are going to be less than 125. And if we say 40, the blocks are going to be more than 125. So clearly, I think this question either meant 123 or 1.6, one of the two numbers. So there is something wrong with this part as per my looking at it. Then the following linear pattern is given. Find the value of x. So grade 10, whenever we have such a scenario, it's all about comparing the common differences. You need to get your D1 and also you need to get your D2. So how do we get D1? So we are subtracting this and that. Okay, so 6x plus 4. You're subtracting 4x minus 3. Please do the subtraction nicely. So 6x minus this is a 2x. 4 minus, that is a 7. So this is your D1. Let's look at the D2. You subtract term 3 and term 2. So we have 3x minus 9. I'm having 6x plus 4. Subtract. So 3 minus 6, you're going to get a negative 3x. The negative 9 minus 4, you get a negative 13. So since the common difference of the linear is always the same, equate the two. Tell us 2x plus 7 is the same as negative 3x minus 13. I'll move 3 that side, I'll move the 7 that side. So 2x plus a 3x becomes negative 13 minus 7. So this is a 5x, is negative 20. Divide both sides by 5, x becomes negative 4. So that is how that should have been worked out. And that is number 13. Let's look at number 4, which is the functions. So we are given the graphs b over x. So if the denominator is x, that's a hyperbola. If we have x squared, that is a parabola. Okay, so G is a parabola, and that's a hyperbola. Perfect. 4.1.1, they want the domain of f. What is f? F is the hyperbola. Remember, we say the domain, those are x values. Ne? So this graph, we said, can stretch to the negatives, can stretch to the positives, but it should never cut through the y-axis. So x cannot be a 0. That's how you state it. 4.1.2, they want the range of G. So G, we know that the y asymptote or the horizontal asymptote is 1. So this line is the line of 1, where y is a 1. And that is the turning point of G. So which means G can stretch everywhere above 1. So we're only going to say that y is greater or equal to 1. Okay. Then 4.2. They want us to get the value of b. Now, since we know that b is the only point that is shorting, what we need is one other point that is passing through f. So f, we don't know the y coordinate as much as we know the x. We can use this point because this is the x-axis, and along the x-axis, we know that y is a 0. So this point is like 2 and a 0. So I'm going to use this and replace it there. So where I see f of x, that is the same as a y. Okay, so this is the same as y is equal to b over x plus 1. So where I see y, I'll put a 0. I have my b over 2 plus a 1. Move the one that side first. So you have a negative 1 is equal to b over 2. Multiply both sides by 2. So which means b is negative 2. So in this case, we can see clearly that even the arms are in quadrant 2 and then quadrant 4, which means our first part there has to be a negative. So that is that for 2 marks. Then 4.3, determine the equation of G if the x value of the point of intersection of the two graphs is negative 1. So it's 4 marks. Okay. Now, since we now have the value of b as negative 2, we need to find the y value at this point. And then that point is what we're going to use in the equation of G. What am I saying? I'm going to say that now my f of x is the same as negative 2 over x plus 1. Now I'm saying if x is a negative 1, that's going to be like negative 2 over negative 1 plus 1, which gives me a positive 3. Okay, so that point of intersection for the two graphs is going to be negative 1 and 3. This is what I'm going to use when I'm getting that missing point within the G, because I know that Q is the y-intercept, which y-intercept is a 1 already. Okay, let me just jot it this side. Let me jot it this side and say that we said AX plus Q. We say G is AX plus Q, but Q is a 1. So which means G of X is going to be A of X plus 1. Then at a point of negative 1 and 3, at a point of negative 1 and 3, I'll do my substitution. Remember, G of X represents Y. So 3 is equal to A, which I don't know, but my X is negative 1. So negative A plus 1. Move the 3 that side. Does this make sense? Something seems off. Let's see. What did we do wrong? Something seems off because it's A squared, AX squared. Let me just erase this. Okay, so remember we said A into negative 1 squared. Okay, when I move that, I get a 2 is equal to A. Remember, our graph is a smiling graph, so the A has to be positive. So G of X is the same as 2x squared plus a 1. So that is what they wanted us to get. All right, then for which values? Oh, write down the equation of the line of symmetry of F, which has a negative gradient. So equations of axis of symmetry for the hyperbola, they are always given in the form of y is equal to x plus c, and then y is equal to negative x plus c. Now, when they talk about a negative gradient, which means we're going to use this kind of equation. For us to get the value of c, you look at the points where the asymptotes are meeting, and those points will be 0 and 1. Okay, because we see this asymptote, and then you see this asymptote. So at a point of 0 and 1, so where there is y, put a 1. Where there is x, put a 0 plus c. So which means the equation is negative x plus a 1. Then for what values of x is g decreasing? G. Where is g? Where is it decreasing? So when it is moving in this direction, that is a decrease. When it's moving that direction, that is an increase. Okay, so it's decreasing on the left side of the y-axis. So we're going to say that x must be less than 0. Then where do we find f to be above g? So f to be above g, that's what it means with a greater sign. F to be on top. F to be on top. So we can see at this point of negative 1. Okay. On the left, g is on top. And then to the right, g is above. So the f is above. Okay, f will be above. So we're going to say that, because if this graph continues, that's how it's going to be. It's going to always be above the g. In this case, it's below. So let me just say between negative 1 and 0. Between negative 1 and 0, because now after that, both graphs are just increasing. So I'll say negative 1, okay, is less x, is less 0. So those are the intervals that I need to get. Then 4.6, calculate the y value when the horizontal distance between the arms of the parabola is 6 units. Calculate the y value when the horizontal distance between the arms. Horizontal distance between the arms is 6 units. What does this mean? Let me just read the question again. Calculate the y value where we get the horizontal distance between the arms of the parabola. Between the arms of the parabola. What do you mean? Because the parabola of this and this, if the horizontal distance is 6, what do they want? So they're telling us that is a 6. Are they asking for the x values? Calculate the y value where the distance is. Okay. So I'm going to get my, is it going to make sense though? If I say the 2x squared plus a 1 is equal to 6. That don't make sense. If the horizontal is a 6. Let's see, if I say 6 squared plus 1, does it make sense? That's 72. No. If the horizontal is a 6. Okay, so what that means is that we must have 3 units this side. And then we must also have 3 units that side for us to have a 6. That's the logic that I'm trying to look at. Okay. Let's see. If x is a 1, what is y? If x is a 1, I'm having 2x squared plus 1. I'm getting a 3 over y. Okay. That is 1 and 1. That is 2. Then if I move on and use x as a 2, if x is a 2, that's going to be 2 times 2 squared plus 1. That is 8 plus 1. That's going to be 9. In other words, if I look at 2 and 2, I'm getting y as a 9. Then 3 and 3. So which means I need to use 3 and 3. Okay, so it can't be 6, it will be a 3. So it's going to be 2 times 9 plus 1, which gives us a 19. That's what I'm getting. So when y is 19, then everything will be a 6, the total distance. Then write down the equation of k of x if k of x is negative g plus. So we know that g is 2x squared plus a 1. Now they are telling us we multiply g with the negative 1. So negative 2x squared plus 1, and then we plus the 3. Open it up. Negative 2x squared minus 1 plus 3, which is negative 2x squared plus a 2. So that is the k of x. Then question number 5, still to do with functions. Exponential graph is given. Write down the equation of the asymptote. So the last part, we said is always the asymptote. So I'm going to say y is equal to negative 1. Calculate the x-intercept. We said y has to be a 0. I'll put it here. Where there is y, remember I said h of x, k of x, everything of x is always the y. So 0 is equal to 1/2 times 2 to the x minus 1. When I move the 1 that side, I'm going to have a 1. Then multiply. It's okay. Let me just go bit by bit. Multiply through by 2. 2 is equal to the x. Because like times 2, and then times 2. This 2 cancels out. So which means my x has to be a 1. And then they want the y-intercept. X must be a 0. So 1/2 times 2 to the 0 minus 1. You know that anything to the 0 will always be a 1. So we have a half minus 1, which gives us negative a half. And then they want us to do the sketch. So let me just try to sketch it aside and see. So we have something like that. So you can still use your table method, but it will take some bit of time. Okay. So we said x is a 1. That is the x-intercept. Okay. And then y is going to be negative a half. Y is going to be, I'll say negative a half. Our asymptote is negative 1. Doesn't matter. You can just put it as negative 1. So that is the asymptote. So we can even see, even if we don't know the direction, the graph cannot move in this direction now. It automatically has to move in this sort of direction because it's an increasing graph because of the critical x. Then after sketching, they want us to write the equation of the graph on if G is reflected over the asymptote. So reflection is like it's bouncing off to the side. And then we have this. So it's more like a reflection about the x-axis in this sort of form. So what that is going to be is we're just going to multiply the whole thing by the negative. Okay. So I'm just going to say y is equal to negative a half multiplied by 2 to the x minus 1. Because we are reflecting about the asymptote, not about the x-axis. So that would be the graph, or that would be the equation. Question 6. When Kossi family of 3 from Dobsonville wish to attend the so-called clapping for TAP 2022, the cost of the tickets is 2,150 per person per game. The family would like to attend the last 4 games. Okay. Then the total cost in rands for the ticket for the family is what they want us to calculate. And this is the exchange rate. Now, if it is 2,150 multiplied by 4 people, how many people in the family? The Nkosi family of 3. Okay, multiplied by the 4 games they want to attend. So 3 people multiplied by 4. What we end up with? 2,150 times 4 times 3. That becomes 25,800. 25,800 Qatar reals. Okay. Then if 1 real is for this much, I'll just say real is 4,012778. I'll put this on the side of the Qatar real, which is 25,800 is equal to what I don't know. Divide this, multiply by that. So if I get that multiplied by 4,012778, I end up with a big number. It's 103,529,67. So in other words, you have to pay 103,529.67 rands. Then 6.2, on the 1st of January, Nkosi invested 50,000 at a simple interest rate of 13%, determining whether the value at the end of 2021 will be enough to cover. So we look at the whole of 2019 as 1 year, the whole of 2020 as another year, 2021 as the 3rd year. So in other words, we're investing the money for 3 years. So A is equal to P into 1 plus IN. What this becomes, our P is the 50,000 that was invested. 50,000, 4 zeros. 1 plus 13/100 multiplied by the 3 years. We Get the answer. I'll say 50,000 into 1 plus 13% times 3. We get 69,500. Okay. Okay, determine whether the value at the end will cover. How many years do we count? 1st of January 2019. So 2020 is 1 year. 2021 is another year. And then 2022 is another year. Whoa. Wait a minute. They say up to the end of 2021. So the end of 2019 is 1 year. The end of 2020 is another year. The end of 2021, yeah, those are 3. So 69,500, which is fine. Then the conclusion will be the investor determine whether the value will cover. The answer is a no, because it's less. 69,000. We need 103,000. Then would the family want a strong rand or a weaker rand when they purchase the tickets? Give the reason. So in this case, when you look at 1 rail, you need 4 rands and something just to get 1 rail. Okay. So which means the rand is a bit weaker when you compare the 2 currencies. So for people to gain more, they need the rand to strengthen, because when the rand becomes strong, it's gonna cost you less to purchase 1 rail. So we're gonna say a strong rand. Okay, because a strong rand will offer you more rails. Then the inflation rate over the last 4 years remained constant at 0.5%. Calculate the cost of 1 ticket in 4 years or 4 years ago. How much is a ticket? The inflation rate over stay the same. So when you talk about inflation, that is more like compound interest. Okay. The cost of the ticket was 2,150. 2,150 currently. Then how much was it back then? So we're looking for the P, and we say I to the exponent of n. That's what we're using. So 2,150 is equal to P into 1 plus 0.5 over 100 to the exponent of 4. Simplify your right-hand side and then divide it by that side. So 2,150 divided by 1 plus 0.5 over 100 to the exponent of 4. So the answer we get should be slightly smaller than what we currently have. So 1 plus 0.5 over 0.5% to the exponent of 4. So I'm getting 2,107.57. So that is the cost of the tickets. Question 7, which is probability. 2 events A and B, which are not mutually exclusive. You're given the following information. So mutually exclusive, we say events can happen, but these ones can happen. That's why they say they are not. Okay, probability of A is 0.45, probability of what's going on? Probability of A is 0.55. Probability of A or B is that. Let the probability of A and B be X. Draw a Venn diagram for the above. This is not making sense, but let me just put a prime there, then it will make sense. Okay, because we can't have 2 probability of A's. So when you're drawing your Venn diagram, okay, so you're gonna have A and B. They say these ones are not mutually exclusive. So which means there's an intersection. So we don't know what the intersection is. So we can put here x. A alone is 0.45. So this is going to be 0.45 minus x. Then we know that whatever is outside of A is 0.55. But the union, everything must give us 0.8. Wow, it's a bit tricky. It's a bit tricky because the complement, what is outside of A is 0.55. So if I get 0.8, I subtract 0.45. 0.8 subtract 0.45, I'm getting 0.35. So that is going to be the B alone. 0.35 B alone. Okay. Then, if this O is 0.8, which means I'm shorting with 0.2 to give me a total of 1. Because remember, probability must always be 1. So this is my vendor. Then they want us to determine the probability of A and B. Probability of A and B. Okay, so what do we do? What do we do? What do we do? Because if I get this outside of A is 0.55, which makes sense. If I look at this and this, and get 0.8. Would people help me? Help me, help me, help me. I can use that, what is it called? The addition rule. Let's see if we shall get an answer. It's saying probability of A or B is going to be probability of A plus probability of B minus the probability of A and B. This A or B, they told us it's 0.8. Let me just put it there. Is equal to probability of A, which is 0.45, plus probability of B, the whole of B, I'm going to say 0.35 plus X. That's not going to be, as I say, 0.35 plus X. Because now this is going to be the X of its own. X of its own. Unless if I do this. Unless if I do this. I look at the 0.45 minus X. X. And then the 0.35 plus X. So this, I'm saying 0.45 minus X. It's okay. 0.45 minus X. This is 0.35 plus X. And then this is going to give me minus X. Let me try to use this side. This gives me 0.8, which still doesn't make sense for me. Oh, this is gonna make me change my vendor because then it won't be making sense if I put it that way. Let's see. So what I'm going to do, let's see. I'm going to say, if this is my A, I'll make this X to be 0.45 minus x. Okay, we already said that that's a 0.2. What is outside of A is 0.55. So this part alone, because it's outside of A, I'm going to make it 0.55. Mm, Okay, will that help? Let's say probability of A. Let me just move this side. Let's erase this out. So probability of A or B will give them 0.8. Probability of A, they gave us 0.45. Okay. Probability of B, the whole of B, I'm going to have 0.55 plus X. So it's going to make sense. Because this 5 is like A only. So I'm going to say 0.55 plus X. But then the intersection part is not going to make sense. It's not. Because if the whole of this is 0.45. Now, guys, let me redo this thing and see, because it's not making sense for me. Maybe even the representation, the changes I made for A, I don't know, might have been wrong. Let's see, if I call A to be 0.45, and then they say complement of A, because when they say A complements, like what is outside of A, what is outside of A? Oh, which means it's a B, which is 0.55. Okay, then this will be a 0.45 minus x, 0.55 minus x, and that's our 0.10. Nice, okay, let's keep it that way. Then A and B, then we shall have the 0, let me just use what is inside, 0.45 minus x plus the x plus the 0.55 minus x plus the 0.2, we must get a 1. So when I add 0.45 and 0.45, that's giving me a 1, plus that I'll get 1.2. This and this cancels, minus x is equal to 1, which means my x is going to end up being a 0.2. Then probability of A or not B. What that means is now I'll have to get, if I have 0.2 as my x, I'll subtract. This is going to be 0.25. Okay, subtract, I'll get a 0.35, just as what we had done initially there. Okay, it's fine. Then we move on, A or not B. So that's going to be 0.25, which is the A only, plus the 0.2, since it is part of A, and we say not B. So I think I'll have to add the 0.2B, since it is outside of B. So 0.25 plus 0.2 plus 0.2, that should give me 0.65, pretty much. All right, then 7.2. 7.2. In a survey that was conducted, 80 people were questioned about their preference between an iPhone and a Samsung. Oh boy. The results show that 30 prefer iPhones, while 45 prefer Samsung, and 12 prefer neither. How many people prefer both? So start by coming up with just a sketch still. Okay. So if this is the iPhone, this is the Samsung. Okay, iPhone is how many people? We're looking at 80 people. iPhone was 30. Let me call both to be X. This is 30 minus X. Samsung was 45 minus X. Neither is a 12. Then I'll add up everything equal to 80. So 30 minus X plus X plus a 45 minus X plus a 12 must give me 80. This cancels that. 30 and 45, that's 75. 75 plus 12, that is 87. So 87 minus X is giving me 80. Move the 87 that side. Negative X is equal to negative 7, which means 7 people like both. How many prefer both? That's what the question was asking for. Okay, guys, thank you very much. That is the end of the prediction and work out of paper 1. So please just practice around the same margins. Let's meet in the prediction of paper 2. All the best in paper 1.